Alright guys, so what we're going to do is run through a series of reducing radicals from the simplest version on down to more difficult stuff. So the first thing we have here is the square root of 28. The whole art of reducing radicals is to know your perfect squares off the top of your head. And what we want to do every time we see a radical is break this number down in terms of factors, but we want one of those factors to be a perfect square. So when I think about 28, I think about 4 times 7 is 28. Now, I have other choices. 2 times 14 is 28, but 2 and 14, neither of which are perfect squares, so it doesn't get me anywhere. But 4 times 7, 4 is a perfect square, so we can break this down into two radicals. Radical 4 times radical 7, and the reduction of radical 4 is positive and negative 2. Radical 7. And there you have it. Alright, now we have two radicals multiplied by each other. It's important to take note that both of these are square roots. If these weren't both square roots, then this is not applicable. But since they're both square roots, what we can do is we can put them underneath one square root, and as I bring them over, what I'm going to do is sort of disagree with the book's method on this one. I'm going to break these guys down in terms of factors, and hopefully some of the factors are the same, and I'm going to force that to happen. So 2 times 5 is 10, so this is my 10. And then I'm going to bring the factors of 15 over. 3 times 5 is 15. And now all of these factors are underneath the radical, and they're attached by multiplication. And so I have this little saying. If I see it twice, I can pull it out once when I'm talking about square roots. Because 5 times 5 is 25, and the square root of 25 is 5. So when I see two 5s underneath the radical, I can pull one 5 out, leaving underneath the 2 times 3. And so our final answer is plus or minus 5 radical 3. Next. What if we start with radicals that have multiples on the outside already? So we have a constant out here times the square root of 35, 2 times the square root of 14. Just have to keep in mind that everything here is attached by multiplication. And whenever that happens, I'm pretty comfortable with this. So what I'm going to do is sort of use the rule of thumb that order doesn't matter when I'm talking about multiplying. So this essentially is 3 times 2 times radical 35 times radical 14. And now I'm going to take from that last example, radical 35 times radical 14, I'm going to put that under one big radical, and I'm going to go ahead and multiply this 3 times 2, giving me a 6 radical, and then I'm going to factor these along the way and say that's 7 times 5 and 7 times 2. Again, keeping in mind that if I see it under twice, I can pull it out once, because 7 times 7 is 49, and the square root of 49 is 7. So I have 6 times 7. When that 7 comes out, don't forget that the 6 was attached by multiplication, and anything that comes out of the radical will still be held to 6 by the application of multiplication. It's kind of a tongue twister. So 7 came out, and what stays under? The radical 10. Then we just want to clean that up. Take into consideration both signs, that's plus or minus 42 radical 10 as our final answer. Now we move on to division. And division is sort of intuitive if you understand the multiplication piece. When I had two radicals attached by multiplication, I could put them into one radical. And if I had one radical with factors, I could pull them apart into two separate radicals and use the fact that one of them was a perfect square to reduce. Well, the division is sort of the same situation. If I have one big square root over two numbers, well, what I really have is a square root over the numerator and a square root over the denominator. Square root of 5 divided by the square root of 36. Okay, well, the square root of 5 is not reducible, so I'm just going to leave it as the square root of 5. Square root of 36 is 6. So my final answer would be, of course, the positive and negative version of radical 5 over 6. Alright, now I'm going to add my own little flair to this one. I've sort of jumbled together multiplication and division. So we have this 2 out here. First, we need to be comfortable with what's this 2 doing? Is it part of a numerator? Is it part of the denominator? I think we're pretty comfortable with the fact that technically that's over 1. So anything that comes out of the numerator, I will multiply by 2. Anything that comes out of the denominator, I'm going to multiply by 1, or essentially let it be. So I'm going to say that's 2 times radical 12, but instead of writing radical 12, let's factor it along the way, keeping in mind that I want one of those factors to be a perfect square. 4 is the perfect square. All over radical 25, and we'll simplify that soon enough. So that's going to give us 2 times radical 3 over 5. And then we just want to tighten up that last answer, keeping in mind that that 2 was the square root of 4. 2 times 2 is 4, radical 3, all over 5, and I'd like to consider both the positive and negative version of that answer. And there's our final answer. And that's about it for reducing radicals on their own, reducing radicals using multiplication, and using radicals involving addition. After that, we'll move on to another video and talk about rationalizing the denominator.